name's John Miner. If I yawn, and I'm going to turn off my camera in a minute or two, it's very early in the US. I live in Rhode Island, which is New England. It's still part of, England. So we know all about colonization back in the day, right? And I'm going to talk about how to practical data engineering with Spark, okay? But right now, Ashan asked me to talk a little about big data, okay? There's two ways to do big data. There is schema on read and schema on write, right? So schema on write is technologies that are more database related, and they use something called divide and conquer, right? So they're MPP, okay? So multiple parallel processing, and two products that are currently out there that are very popular are again, I'm going to name Microsoft first because I'm a Microsoft MVP. So Microsoft has Synapse, right, which is an MPP appliance. It used to be Azure Data Warehouse, and we also have Snowflake. Okay, now Snowflake, okay, looks a lot like Databricks. Okay, and Databricks is Spark. Okay, and also Synapse has a Spark component. Now, what's the difference? Schema on write, okay, which is the MPP, is you have to define everything ahead of time. You have to define a table and you put the data into a table. Schema on read, which we're going to talk about today, is you basically doing working with files, and at the time you go to read the data, okay, you have to know what the structure is, okay? So you can infer it. If it's a type like CSV, you might be able to infer the CSV file. Hopefully it has a header. Again, data types are tough to determine because it has to actually scan through the file to figure it out, okay? And also, you can pass that schema. And we're going to talk about different file formats that are very popular, okay, in Spark today. With that said, I'm going to turn off my camera. I'm going to show you a couple links. One is to the presentation materials here, as well as some additional information that you might enjoy. And then we'll get into it because we're about 10 minutes late and I'm going to be tough to get this in an hour, okay? So I'm going to turn off the camera. I'm going to share my screen. Okay, so this is the presentation, but I'm going to minimize it for a second. Okay, and I'm going to switch over to some tabs here. So first thing is, if you're curious, I'm an MVP and I do talk at a bunch of places. I also do writing, okay? So I'm going to minimize that. Second thing is that there's a bunch of topics I've written in the past, okay? They're in-depth articles. I like to talk about technology, and one is Apache Spark. And if we go in there, we can see that one of them is data engineering. So if you're interested, take a look at this article. It's pretty good. If you go to GitHub, John Miner 3 community work, okay, and go down to, master and practical data engineering, everything's here that we're going to talk about. So abstract, lesson plan, PowerPoint, and code samples. And code samples is what we're going to go over. It's provided in two different formats. We have Jupyter Notebooks, okay, and Jupyter Notebooks is how you interact with the engine, okay, and we'll talk about that. And we also have Python, okay? So don't get scared yet. You only need a little Python to do data engineering. We'll talk about how to do it. Last but not least, this is Azure, okay? And I actually pinned, okay, what's important to the dashboard, okay? So this is the Databricks class demos, okay? And what I do is I have two versions of it. One's like a personal version, one's like the demo version. Components that you usually use in a Spark design, okay, are usually some storage, okay. You could use local storage, but the problem with local storage in Databricks is quite limited, okay. And you can also use remote storage. This is actually Azure Data Lake storage. You can notice that I'm using a name convention here. And again, you can come up with your own. For demos, I made it quite simple. I'll try to go ahead and increase the size. We can see that DBS is for Databricks service, and then 4, I just put it, and this is my user group, RI, which is Rhode Island, SQL Server user group, should be DP, and then I just came up with 2020 I started talking about it. Last but not least, we have Key Vault here. And Key Vault is where you want to put secrets. We never want to store code, secrets in code, because if someone sees a secret, then suddenly exposes. Now, there's a couple pieces that actually get deployed, okay, with Azure Databricks, okay? For instance, you got a VNet, you have a network security group, which is securing the VNet, and you have a storage account. So let's go poke at the storage account, see if we can get in. And I just want to show you this, and then we'll get into the presentation. We can see that this is root. Oh, maybe I can find out what's inside the storage account, right? And guess what? We get no access, okay? So even though, and I deployed it specifically with an ARM template so I could divide them into two resource groups. But this storage count, while everything is here and it's finite in size, is called a managed storage count. You really can't do anything with it. Now, if we click on it, okay, we're going to see that I started my cluster. And what is a cluster? Well, a cluster is actually just a virtual machine. I asked for a um, 3-node cluster. One is actually the executor work node, and the other two the workers. And if we look at it, and this is why, things like Snowflake, Databricks, Synapse, they're all very popular is because they're using cheap compute. And we can look underneath and it's running Linux, okay? So it's just basically doing the concept of divide and conquer, okay? So I talked a lot, but I didn't do any slides. So let's get in the slide decks and hopefully reinforce what I just talked about, okay? So, and I'm definitely running tight on this. So I'm gonna have to skip some things. So we're gonna talk about practical data engineering with Spark. There's many companies moving their workloads to the cloud, right? Into these big data lakes, okay? How can you become, part of this movement, okay? Well, if you're a SQL developer and you have existing SQL skills, you can take advantage of this, okay? And today we're going to introduce you the concepts and code that help you during this transition. Topics. We're going to talk about the Spark ecosystem. What is Spark? We're going to talk about storage management, data engineering, and tables instead of files. So here's some icons here. Spark is a section of collection of different technologies, and we'll talk about that. This is actually a storage. Okay, PySpark is a wrapper for Python that allows you to talk to Spark. And Hive, okay, is a technology which you can expose files as tables. Okay. So Spark ecosystem, I'm going to talk about various components, cluster management, organizing code with notebooks, and scheduling actions with jobs. So what is Spark? Spark's a unified processing engine, and it allows you to work with big data. You can also do machine learning, so that's this part right here. You can do graph processing, and you can do streaming, okay? So typically, when you work with data engineering, we're going to be talking about data frames and SQL. I don't have time to talk about the other ones, but machine learning, you can figure out, hey, can I predict something? Graph. How can I travel from one point to another? Is the easy way to use graph, right? Streaming. I have stuff coming from IoT to Event Hub. How do I grab it from Event Hub, which is a Kafka compliant service, to actual storage? So let's talk about how I showed you the VMs, how they work, okay? I write a program, I connect to the cluster and I say run. Okay, how does it work? Well, you have that one node because I had a 3-node. We could see that would take these two and throw them away. One's the driver. It tells it, hey, I got a program. How do I parse it and execute it? And it coordinates how to divide and conquer between the two executors. The executors have something called task. Okay, and we can notice very important that it says JVM. We'll talk about why JVM is really important in the next slide. Um, Within here, you have slots. Each place where it says task is a slot, and that's basically just like CPU. And so what it does is it divides and conquers the program into Java virtual machines, and then it runs one or more jobs on each of the executor. So that's how it distributes the processing for parallel processing. What's important behind it, just like SQL Server, is there's an optimizer, okay? Now, I said it was JVM. Why is it really important? Well, Spark is written in about 600,000 lines, and I'm just guessing, but that's what I heard last time, the amount of lines of Scala. Now, what is Scala? Scala is object-oriented Java, okay? So and what that does is the catalyst optimizer converts the notebook code into a model. So it goes through this, and it uses something called resilient distributive datasets. And it's all in memory, so that's why it's fast, okay? So we're just using the memory, not using as much disk on each of those JVMs. Why does it have 3 inputs here? Well, the first input I said is you work with a data frame. So when we do spark.read, it brings it into a data frame. But once it's a data frame, we can cast it to a view. And once it's a view, we can use SQL. And we're going to talk about that paradigm, okay, in this talk. What is data sets here? There's some languages that are very types safe, such as Java. Python, on the other hand, doesn't really care about the type, so it's a data frame. But Java does, so that's why it's called a data set. And I don't have time. Again, I'm going to have to cut through some of this stuff really quickly because I'm short about 10 minutes. But it just takes a regular plan, and what it does is it creates a uh, logical plan, and then it creates a physical plan, does some cost model, and then it selects the final one. The one thing you should know about Spark is there's something called the RDD, which is Resilient Distributed Data Set. And how does it work? Say we read up a salary file from a CSV file. Okay, so Spark.read, boom, we get it into memory. Say we wanted to give everyone, the company's doing really great, a 5% bonus, right? In their salary. So we're going to take the salary and multiply it by 1.05 and then save it. How many RDDs we get? Well, the first RDD we get is when we read it in. Okay. The second RDD we get is when we make a change because it's resilient. We can't, it's immutable. So we're going to make a change. So we get a second RDD, then we're going to write it out. The main thing between open source Spark right here and Databricks is this optimizer. They made changes in Databricks to have it really slick. Let's talk about the interactive versus job versus pool and cluster. Okay, and we see here on this is the design. Okay, so when we want to run anything, okay, we have to actually have some type of cluster to run it. Okay, and what I'm going to do is I'm going to switch over to Databricks to enforce this because just seeing this diagram is not going to really help you. We're going to get into Databricks. So if you click on it here, and you're going to get a entry into Databricks. Okay, let's talk about the actual UI. Um, Everything that you do has to have a cluster. Remember we talked about the cluster? And here is the cluster right here. So we have right now, it's not a scaling cluster, it's a fixed size cluster, has 2 workers, 3 VMs. We got the executor node and the worker nodes. And we can see that it's a standard, okay, virtual machine. It's running Linux we talked about, 14 gigs of memory, 4 cores, okay? So that's how you start it. Data, okay, is where if you have any Hive tables, it'll show it. Okay, so the other day I was talking to a client about, VentureWorks, and guess what? We got VentureWorks here. And there's other databases. So once you have VentureWorks, this is the star schema. That's the very final result of it, and we'll talk about how that came about. What else we have? Compute data we talked about. Down here, you have settings you can do like if you're an admin, you can go to admin console and you can create counts and you can manage accounts and user settings, right? You can search repos. Repos are really important because when we write code, we want to check it into some type of source safe, okay, for version control. And you can write pipelines, say in Azure DevOps, to move code from one environment to another. The workspace, okay, which is here, allows us to divide things into different places. So this is my daughter. She does work with me once in a while. And so, I did some, video capture with her. But we're talking about practical engineering. Here's another bucket. This is a shared workspace. Okay, it says shared. But you can also have users. And say if I gave Dilbert no access to the shared workspace, he only has his local space, then he could have his notebook here. And if we went into test, we could say, hey, this is a notebook. Now I'm going to go really quickly of right now, if I tried to run this, it wouldn't work. Okay. If I attach to the cluster and hit confirm, it works. And now I could go ahead and say, hey, I want to use the star. And that was down here. This compute was a star schema, which is a Hive database. And then I can say, this is a magic command. That's why it's obscured. This is Python. If I'm running a magic command saying, hey, I want to do spark.SQL, run it. Okay, I'm going to select from the dimension of the employee. And if I run this, okay, because I said use star, it knows that it needs to use star schema. And then when I run it, it's going to pull it back. Now, how is this working? We talked about it. It's going to create a job, okay? And this job has different stages, okay? And if we view into it, Okay, and this is a lot more detail than you really need to know. Okay, it has like, hey, it's going to scan a Parquet file because that's the form I'm using and pull back everything. Okay, so again, you don't need to know the details when getting into this. It also actually, you know, there's executors like we talked about. There's actually the standard and standard out, just like a regular, Java program or C program. So there's a lot of complicated things going behind the scenes, but you don't need to know that unless you're really tuning. So only thing we need to know is, hey, I want to look at VentureWorks and pull back the dimension table for employee, and I did. So I was trying to talk about the compute, and I gave you kind of an overview of Databricks, which is awesome. So how does this work? Well, we have job clusters, and they run when we run a job. It'll create a cluster, and it'll come up and do something. So for instance, I have a job that runs all the time, and if we look at the event log, if I can see it, it says creating, running a job, and then terminating. So it's on there. And if I can look at the output, if I can find it, it runs something very simple. So let's go back to the job. Always forget how to do this, so bear with me. Click on this. Maybe event UI log. That's where we were. Spark UI. Driver logs. Okay, so here's your driver log, and we can see that it actually runs something, but I'm looking for the actual content that it ran. They sometimes change this too, so let me see. Can I go into clone? Nope. Accessible by me, created by me is fine. All terminated. Maybe I can't get it this way, but I thought I could just go in and show me what it actually ran. Maybe go to the job run. That's where it is. Sorry about that. Now I figured it out. Okay. I do a lot of different technologies. Once in a while, it takes me a little while to figure out, hey, it's this button. Sorry about that. But we can see this runs Hello World. That's all it's doing. And this is just and then I talked to my friend Christian, his group, Hello John or Hello Christian. And we can actually mix programs. So I showed you a percent slash SQL, but you can also do %.scala, which is Java, and I can create something in Java, which is a little syntactically different. Var y, print y. This one says just print hello world, but it's the same thing. So going back to compute, and this is a little more complicated talk, and that's why I wanted to show you this to build it up. Okay, job clusters is where you run a job, and it's just you can set it up and it runs, right? You can also have an all-purpose cluster, and that's what we're using right now. Okay, but what is a pool? A pool allows you to say, hey, I want to carve, okay, this cluster out of the pool. How does that work? Well, I'm going to say in the pool, okay, I want to have a maximum 18 nodes, okay, 18 virtual machines. And if I'm carving this cluster out of the pool, okay, every time you set these up, the most important thing about doing a cluster is to click this button right here. This says terminate after n number of minutes, okay? So I'm not gonna, after 120 minutes, which is 2 hours, it's gonna close down those 3 virtual machines. If you leave them on for a month, it's gonna cost a lot of money, right? So it's a really good practice to do this if you're interactive. There's an interactive cluster. Job clusters, they spin up as we see and spin back down. Now, the problem with a spin up and a spin down is this, it takes time to, allocate 3 virtual machines, spin them up, put code on it, run it, and then close them down, right? Maybe 5 to 10 minutes tops, depending on power. And we're going to incur that every time we run a job. Well, it's going to take forever to do data engineering because if I have 100 different jobs I have to run, I'm incurring 100 times 5 minutes, 500 minutes of downtime, right? I'm waiting for the cluster to spin up and spin down. How do I make it go faster? And what they did is they came up with this idea of a pool. So when I go ahead and I say, hey, start this standard cluster, and this one's not using a pool today, but I just wanted to show you what it was. It actually goes and says, okay, is there something in a pool? If there isn't, it's going to spin up, okay, the 3 nodes in a pool. And this has its own TTLY, which is time to live, right? So we could say maybe this is a 6-hour time to live. And I'm willing to eat 6 hours of time to keep it up. So now, guess what? We start another cluster, and the other cluster went down after 2 hours. Do we have to wait? No, well, because the time to live is 6 hours, it never got rid of the resources, okay? So that's what's called a warm cluster, and that's how pools are used, okay? So we're going to go back to this. We talked pretty much about it. I really needed to go and show you the Spark UI because if I just go over this, you're not going to understand it. But time to live is really important with pools, okay? And we have two types, right? We have an interactive, and that's what I'm using now. I show you the job, which will spin it up by itself and down. But if we have this pool sitting here, the automated can be carved out of pool as well as the interactive, okay? Again, we're reducing the time, okay, to spin up the cluster by sacrificing how long we're going to keep it up. Okay. Storage management. So when we talk about working with big data, okay, it's mostly files, right? And the exciting thing about big data is you can do all different types of files. You can do not only structured files, semi-structured files, but things that are not structured, like a video. Well, it's a video file, but there's a bunch of frames. That's about it, right? We also have, audio files. We have images. So with all those though, they're all files, right? So we have to learn how to mount the system, just like Unix, how to work with folders and files, read and write files. How can we read faster with schemas? We're going to talk about, I don't know if I have it in the slide deck, different file types and why certain ones are better. Okay. So let's talk about the database file system. Out of box, right? Databricks system has a local file system and it has a remote file system that can be mounted. I suggest not using a local file system because you don't control the size. And the only time people use it is if you get a really big, file like 4 TB and you have to process it really fast. Sometimes people copy it to the local, do the processing, copy it back. But there's a penalty for that too, right? Because you have to move data from one storage account to another. So there's many ways to work with files. Again, the main way that you can use is dbfs.utils.fs.ls. So what does dbutils mean? This is a package that Databricks wrote. And inside this called fs is the file system. ls is a command that we know in Unix, list, okay, cat list. Well, there's abbreviation for %s. Again, it's a magic command, ALS temp. Now we can see nothing's been prefixed here because it natively knows that you want to talk to Databricks. If we use systems like sh, which is a shell command, or we use like a library import OS, which is from Python, okay, we have to prefix with dbfs because it doesn't know it's a dbfs, okay. These ones will not work well, okay, when we do something called a pass-through, and we'll get into that in a minute, versus mounting. So let's talk about the data lake, okay? There's something called Lambda architecture, okay? Lambda architecture is a point where you got data coming in. We talked about streaming, batch, could be semi-real-time, real-time up here, but semi-real-time could be run every 5 minutes, could be just daily or once a day. And we have different zones. Now, zones are how you determine the quality of the data, okay? And that's really subjective. Go ahead. Okay, no question. Great. It's really subjective, right? The bronze is usually like raw, and we could put the word raw here. That's kind of like when we land the data. So we might land the data in here as raw, right? And we might use a delta table. Now I'll talk about delta tables in a minute, but they're really exciting because they have ACID properties, just like a database. And when we go from bronze to raw, we might get a bunch of full files and then incrementals going forward. That would get us to have a large table look like a table in the Delta format here. So say we brought over VentureWorks, okay? We might want to combine VentureWorks to in the gold and publish it as like I did as Hive. Or we could even combine it and come up with new exciting things. We could do ML on this. We could go ahead and flatten it out for reporting, whatever. At the very end, consumption is AI and reporting. So this is the data architecture future that was designed by Databricks. So how do we manage mounts, files, and folders? Okay. Um, we can use Databricks to create, copy, rename, and delete both files and folders. It supports both session and service level connections to storage, and that's why I suggested using mounted versus pass-through. Okay, and Key Vault back secret scope, we can do that. I'm going to show you real quickly how to manage local and remote storage. Okay, I'm going to do a demo. So if we go to back to here and we go to workspace, we're gonna, again, it's a shared workspace and then practical data engineering. And did I go up one? Sorry. Shared practical data engineering, and we're talking about storage, right? So real quickly, we can do fs and it tells us, hey, what's the available commands? We can see there's a mount command, there's a bunch copy, head, ls, make directory, and so on, right? Gonna go down really quickly and do an ls. If we do an ls at the top level, we can see there's a bunch of different files, okay? Now, one of the things about the GUI, okay, is that when you get a grid, and they call this a grid, okay, you can do graphs, okay? So I can do a graph, but it didn't make sense, right? And that's why we get garbage there. Put it back to here. So this is actually an object and we're getting a graph. This one's actually just a list, okay? Inside the list, we have a bunch of objects, file path info, and that's a dictionary, and we have a path, a name, and a size, okay? So depending upon, okay, what command you use, you get different output, okay? That's the main thing. We can also manage storage, so we can say, hey, is there a lake? If not, create a lake, right? And this is all local because we see nothing here going on, okay? So why don't we actually take a look at this? We're gonna go back to here and we can see there's a lake, right? I'm gonna just change this a little while I'm talking. So I'm gonna do fs and I'm gonna do ls slash, we don't have to do it, lake, and hit enter, right? And it's gonna take a second because we have to get to the cluster. Hopefully it's not a cloudy day and we're having issues. So let's talk about the example while it's coming up. I was trying to do a listing of the lake. One of the things we want to do is when we write stuff and there's a possibility of an error, we want to do error handling, right? So this one's a try command in Python. And try means try to do this. If not, accept it, which means catch the error and then continue. So I'm going to try to recursively delete the sample data lake. Then what I can do is I can make what we just talked about, a lake directory, and we can do bronze, silver, and gold, and then ls it. Okay, and so we can also look at sample files. And again, I don't know why this is taking so long today. Sometimes clusters do get in bad states, and if it does, we can always hit a restart cluster. Okay, so let's see what's going on. Yeah, I'm gonna cancel it. That's really weird. Okay, I'm gonna talk about the demos because I still have the output, and then we can go back to the slide deck. So some of the things we can do is we can look, there's a bunch of Databricks data sets. I suggest you play with these because they're pre-built data sets there available for you to work with and learn, okay? And that's how I learned, Python. I've been doing this about 2 years solid on and off between different, systems, either doing MVP work or doing Spark work. Um, in here, Databricks is a power plant. Okay, and if we're curious, we can use databricks.head, which is like a cat command. Give me the first 1,000 rows, and I can see information about the power plant. Okay, we can also do an ls, and we can see there's actually a tab separated value files, TSV. Okay, so we got 4 of them. We can also take a look at the head of the first file. We can see, hey, look, there's a header, and this is why this is called a weak, okay, file format because we could break it by taking a text editor and putting another tab in, and it would think there's 5 columns, but then on the first row, try and put John. And then the next one would break because it would only be 4 and say, hey, where's the net fifth one? And it would error out on a load. Okay. We can also write to storage. So there's FS, which is the library, put, and we could say, hey, in Insight, create hello world and say this is my first program. Okay. So we can also show in the new file, right? So ls, it's there, and we can remove the new file, right? So let's try running this guy and see if it works. Hopefully my cluster's not dead yet. No, I'm gonna have to restart it. While that's running, I'm gonna talk about, we can also write to external storage, okay? So dbfs mount hello world, we can open up the path, we can write this is my first program and close it, and guess what? It should do something similar to hello world. And then we can look in here, there's a package called glob, and then there's many different ways to do it. We can also do OS walk, and we can do files, and I'll show you, hey, by the way, I have this AdventureWorks, and I can see that all AdventureWorks files are coming in with CSVs. Okay, so there's many different ways, again, to work with it. And then going back to it, basically you can use the OS or commands from Python, or you can use the one Databricks. Okay. Um, I'm going to go ahead and go back just because we're running out of time. So we talked about mounts, files, and folders. I need to show you the mounts, and the problem is I'm having issues with this cluster. So I might go ahead and just do this and confirm, restart it. I'm going to restart the cluster, bite the bullet, and I'm just going to show you with the workbooks. So we can use mount. Okay. So again, I'm suggest that we mount a cluster versus doing pass-through. I'm not going to talk about pass-through today. And how do mounts work? Okay. So now what we need to do is this one, Databricks, and again, this is a IPython, okay, frame, okay, it's Jupyter Notebooks, okay, and it's still thinking on how to reload this, okay. But what's the top over here? This is something called widgets, and this is a really important concept. Widgets allow you to pass parameters, okay, to a notebook, okay, and that allows you to dynamically change what it does, which is really, really exciting, right? So right here, we can see this DB utils widgets text. It actually creates them the first time. You could put a pound in front of it after you do it the first time, or just leave it there. It won't do anything the second time. The main thing is we want to get, okay, the secrets, okay, for each one of these. So we went ahead and we have, now why do we need secrets? When we mount stuff, we have to have mounted, okay, under a, why is this still not working? This is crazy. It's going to be an interesting presentation. Wow, cluster. But in the Key Vault, this is a secrets. Okay, secrets is like a Key Vault. This one actually is backed by a Key Vault. If we go back to here, right, we can see this is Key Vault. And inside the Key Vault, those secrets, okay, that I showed you are right here. So we have a key, okay, for the client ID and client password and tenant. What is this? Well, this is actually something called the service principal. Service principals are a way in which you can create a non-user account, okay, that's only used for system access to do things, okay? So tenant ID is the tenant ID of the subscription. And what we do is we actually create a service principal, and it has a client ID, which is basically the username to GUID and a password, GUID. More about that, go back to my blog and you can read about it. So this information is stored here. And there's a reason why it's stored, and there's also a key to actually encrypt stuff. The reason why it's stored here, and did this actually come back? Okay, let's get out of here and try rebooting this thing. Okay, let's go ahead. Did it do it? Come on. You gotta do me something, otherwise it's gonna be real. Okay, finally. Phew, worked. Okay, I just had to reboot it. So now what we're gonna do now is gonna run this cell and actually create a myth not there. So we're saying go to the storage account. If we go back here, this is the storage account is right here. Inside the storage account, there's a container. Okay, use this container to mount it. And then here's a bunch of directories: Cloud Driven, Client, Gold, SQL Saturday, Silver, Test. There's a bunch of different directories, okay? So we can see right here, we're going to read up the client ID to mount it. Then we're going to say, grab this information from the widget. Where we want to mount it is on a mount data lake, right? And then we can, let's unmount it first and see what happens, okay? So we're going to run this. And name mount point's not defined because I didn't run everything. So what we need to do is we need to run this guy, get my secrets. Okay. We're going to go get my mount point, which is the widget above. And I'm going to unmount it this time. Okay. So I'm going to unmount it and I'm going to show you what this does. While it's running, I'm going to make a quick change to this program. And hopefully this time this will work. So I'm going to do FS, which is the same thing as dbutils, right? And then I'm going to say, hey, what's our mount point? Well, the mount point is MIT. So after unmounting this, if this works correctly, okay, we're going to see that there's no more data lake under here, okay? And so this should come back with an error. And then we're going to run the mount command. So this is okay, but look, there's nothing there. Let's try this again. There's nothing underneath there for some reason, okay? And so let's try this. I don't know why that's not showing anything. So dbutils.fs. And syntax. I did illustrate. Okay, so there's nothing in that directory, so it's totally empty. I was just wondering why it wasn't coming back. So now I'm gonna get rid of this because I don't want to change my code. And at this point, we're just gonna do an OAuth, pass those client IDs and mount the point. And again, this is pretty standard code. And this will take a minute, and then we can go back and we're gonna put, I should just left that there. Could do it again. And you'll get used to these commands, once you start working in an environment. When I first started, I was really, afraid, hey, I'm gonna do something wrong. You really can't, right? Unless you just delete something. So now I'm gonna look at this and say, hey, is there anything in there? And we can see it's mounted. Now, does this look like what we had in Azure Storage? Let's take a look, because that's Data Lake Storage, and we want to mount it. And the good thing is, guess what? Cloud Driven's there and so on. So now we've mounted it and we can start working with the storage, which is really exciting. So go back to the presentation. I got about 15 minutes. So I'm going to focus more on what's important in the slide decks and then optionally see if I can put one or two examples in. So I thought mounting was really important. Various file types. We talked about weak file type like CSV. Why is it weak? Well, the problem is that it can be easily broken. So if you're worried about security, I can see the data with a text header. It's really hard. Now, strongly typed file format Apache came out was Parquet. It's binary, so we couldn't see it, right? Nothing with problem with CSV is, guess what? Easily broken, we put a comma, carriage return. Oh, we do something like adding a column, boom, breaks the CSV file. Apache file format, because it's binary, can't do it without actually getting a hex header. CSV, well, we got SSN in there. Is it alphanumeric, numeric? I don't know. You have to scan the whole file. In Apache, guess what? We know what the column names are. You don't have to have a first row as a column. And guess what? We know the type. So we know that SSN is a numeric, maybe the way we start it, versus an alphanumeric. And the CSV, it's very hard to compress it, okay? There is something like a csv.gzip, but that's just basically a zip file and it's box spot enough to read it. But again, it's not splittable. And guess what? Parquet can be split into different things, and it uses column store for compression. So let's talk about processing files, right? Weak file types take more processing because you have to infer the data. You have to read the whole thing up, okay? And if you got a really huge JSON file and you got lots of redundancy because all the tags are over and over again copied, then it takes a long time. One things I consider is passing a DDL string for faster processing. And what you want to do is you want to extract and validate, apply the schema. You have to pick some handling, how to handle corrupted records. We won't talk about that today, and then load and automate, okay? So what is it? PySpark is the API for Apache Spark, and it's allowed for large processing of data sets, okay? And there's two things you really just need to know, right? You need to know spark.read and that allows you to read one or more files in a data frame and Spark.write. So I'm going to do example 3 pretty soon, but I'm going to skip over it. Now, anytime that Spark.read, it does it distributive, okay? So it'll go and use as many cluster nodes as it needs to read, and same thing with write. And you can also use partitioning, which is very important. We're going to talk about load patterns, right? There's two types of load patterns. There's a full and incremental. Okay, full means that we got a really small data set. We can just read it up and write it over. Incremental, okay, is when we want to go ahead and have medium to large size. Okay, and you know what? We don't want to bring all the data over every time, right? So we might use a watermark and go back to the source system and say, hey, give me over a day's worth of data. And if we have 2 years worth of data, we might say initially, give me 24 files, one per each month, and we'd incrementally load those into a Delta format, okay, file format, and put a Hive table on it, okay. For larger data sets, not only with that Delta file format, we have to worry about partitioning, right? Remember the cluster works when it's really well, when it's partitioned correctly with the cluster. So if we had 8 nodes and we had executors on the cluster and we partition in 8, then that executes really well. What happens if we didn't have 8, we had 10? Well, the number of stages would change, right? So instead of running it once, we'd have to run it twice. We'd have one stage that would run 8 nodes, and the second stage would run with 2 nodes, okay? So again, partitioning is very important for speed. Working with SQL. So the main thing I want to show you, and again, we'll go back to 3 and 4, is that you can leverage a lot of skills you already know, okay? And how do we do that? Well, we want to take those tables and slap a Hive table on top of them so we can look like a regular database, okay? And it's great for your end users because they don't want to know about files. They don't want to know how to do Spark.read and Spark.write, but if they can do %SQL and run a command, they'll be happy. Sparks.SQL allows you to execute dynamic SQL, and what does it? Returns a data frame, okay? And what we can do is once we have a data frame like Spark.read, we can also do, which returns a data frame, we can also do something called create or replace temp view. And this converts a data frame to a session level view. So with that, we can do all the SQL that we're doing. So we're going to go to example 3 and 4 really quickly, and I might cherry pick from it because we're running out of time. So let's go to example 3, workspace. Um, so we got read and write data sets, okay? And again, we have to attach. This is something called, again, I didn't talk about it. This is something called a markdown. This allows us to bring in graphics. Like I uploaded my little avatar for the Crafty DBA. Okay, and we can also document here. So we can say, hey, what are we doing? We're going to create a local data lake. We're going to read and write files, and so on. I'm not going to go through each one of these. I think I'm just going to skip we already know that we can do ls. We can also do mkdrs. So this is like DOS commands on Linux. I want to make a directory, or we can remove it, right? I'm going to pass all those and look at the ls command. So the ls command here is looking at the weather data. Okay, and we can look ahead at how do we, and there's a high temperature and low temperature. What can we do with it, right? Well, let's read this one up and see what happens. So if we run this one, okay, let's look at the options here. First, it says, hey, we know, okay, looking at the data here, right? It's a comma delimited file, okay? So we see it as a carriage return. We see that the very first one's the first column is called date, the second one's called temp, right? We're bringing it into a data frame here, okay? So now we can see it here. And we can, this is data frame 1, and we can rename, okay, temp.low.temp, okay, because I'm going to try to combine them. I'm going to show you how to do data engineering with data frames, which is a lot harder than doing it, okay, with Spark SQL. So if we run this, we can see now that we have date and low temperature, okay? And if I display it, which is a way to show the data, okay, out of the data frame, we can see, okay, that's going to come back with the first 5. Head means give me 5, and display it, we can see that we have date and low temperature. Perfect. We're going to repeat this, okay, for the high temperature file. So we got a low temperature file, say in Rhode Island, what the temperature was on the 1st of January in 2015. And then this one, we're going to rename it and create day 2 too. Okay, so now we have 2. And if we go ahead and run this head, okay, and I am actually running these. Perfect. Now, how do we join these? Well, we would say, if it was SQL, would say select star from file 1, which would be table 1, join table 2 on date, give me low temperature and high temperature. Boom, done. Well, it's a little more complex to do it in, data frames, not that hard, but, I don't like the syntax. I like SQL. So I've been doing it since 87. So I like SQL a lot versus data frames in the last 10 years. So data frame 3 is equal to data frame 1 join data frame 2. This is the syntax for it. Data frame 1 date is equal to data frame 2 date, and then drop date 2 because we don't need 2. So I can run this now, okay? I'm going to get a third data frame. And then if I run the display, guess what? Now I have date, low, high, okay? And then I can actually say, I think I have to run this because did I do it yet? I wonder. Maybe I didn't. Remember we talked about partitions, very important. RDD, resilient data sets. Well, I'm saying get me the data frame, resilient data sets, distributed data set, and then give me the number of partitions. I want to know it's one partition. So maybe I want to do more than one. I could put 2 here. And I could write this back out to temp. Say, hey, overwrite it and save it. Okay. So if I run this, I'm going to write out the file. Bronze weather temp. And then if we take a look and run this right here, oh wow, I wanted one file. Why is that this way? Well, the interesting thing is that Spark always writes a bunch of files out. So it's going to write out not only a committed file, a success file, start, but part is always what the data is. And if you partition it, say 5, you'd have 5 part files, CSV. Well, a lot of times we want to present the user with a final file. So there is a little utility program I'm going to give you, which is called Unwanted File Cleanup. And did I even load it? That's my next question. I'm going to run this here because I didn't load it. So this is my toolbox code, and it'll fail otherwise. And again, really quickly, %run means run in this Spark process, my code to load it up. Okay. So if I go down here, there's a function I wrote, and you can look at it if you want to learn more about it. It says clean up what's in temp, bring it up one more level, call it temperature.data.csv, and create a CSV file. So now if I run this, and now I look at the temp, it's going to automatically get rid of weather.temp and just have weather now. Oops, and I hit run. It's going to create a single file, okay? Awesome. So now we have something that the end user can use, and there's also a Parquet file. I'm going to skip the demo for there's a lot more here if you want to play with it. Use of temporary views, okay? What can we do? Well, we're going to run this here again. Hopefully I didn't get rid of any of these. So we can create like a bronze, bring over the loan data. Okay, it's just some data and we have a bunch of directory. And so let's do this again, okay? But show you how do you do it with Spark SQL, okay? So I'm going to read in, okay, the data frame file. We've seen this before, right? Now, instead of doing like describe what it's here and show me the data, I'm just going to create a view because I know what's in there already, right? So run it. And now I'm going to go ahead and I'm going to do the same thing for the second file. Okay. And now I can run this. Okay. Now, once you get these views, we can use inline SQL. Okay. And we say it's not going to do anything other than display what the data is, but I'm going to say take the high temperatures, take the low temperatures. These are my temporary views in this session. Give me the date from the very low. Give me the temperature from high and low. If I run it, guess what? I got this, but it's a lot easier to do with that SQL versus actually using data frame dot. Okay. And last but not least, we can put it into a program. So we can do spark.read and we can actually get a file. So I'm going to do that this time. Okay. And now we can do is we can overwrite this with a Parquet and we're going to put it in temp. So again, we're using a temp directory. And really quickly, if we go here, we can do %fs, right? And we do ls and bring in this guy. I don't know if I need quotes or not. Probably not, but we'll see if this works. If not, I'll get rid of the quotes. Run. Come on. Maybe not. There you go. So now we have the same problem. Success committed, but we have the petition window. It's Snappy, and Snappy's compression version, and it's Parquet. So to fix it now, I just run this guy. And guess what? Now I have a final 2 files in there. I got the CSV and the other one. Okay. Definitely run out of time, so I'm going to see if I can get to my slides and finish up. So we talked about table instead of files, right? Delta file format, very important, and I need to get over it, talk about it. So why do you want to use Delta? It's a bunch of Parquet files with log files. It enforces ACID, so it's atomic consistent and independent and durable. You can do time travel because it has the log files. You can go back and say, as long as you don't use something called vacuum, okay, which means get rid of my deltas logs, then guess what? I can go back and say what happened today versus yesterday. So if I did an insert of a customer yesterday, and then today I did delete, if I use time travel and said, what did the data look, show me all the customers yesterday that got deleted today, I could see it, okay? It does snapshot isolation. That means that, say if we were manipulating these files, like a Parquet or CSV file in the past, you could read it up, okay? And you could go ahead and 2 people could read it and 2 people could write it and it would know it, okay? Last but not least, it's open source and even Microsoft's using it. This is a Delta Hive table, okay? And so I'm going to do last, which is exploring dataset with SQL. This section represents designed to reinforce the fact that SQL skills are applicable on PySpark, which we showed a little, and summary. So we're almost there. And again, I did pretty good with losing about 10 minutes. So workspace, again, there's a few things that you're going to have to look up. But so we can create a new Hive database. I'm not going to do it. Just drop database, Cascade, be really careful. And then we can create a new database, right? We can take a look at the bronze. Okay, what's in my bronze, right? And we can see I already have some stuff. Okay, so we get Amazon, diamonds, loan, we talked about power, weather, and we can create Hive tables. So create table, and we can base it using Parquet on the location. Again, use Delta because it has the ACID properties. Multiple people can work on it. And we can post each one of these. So these just creates a bunch of tables, and then we can explore the tables. Okay, so for instance, let's look at the products. And if we hit run, and I'm not going to be able to go through all of them because I got about 1 minute. So we can see there's products, we can see there's diamonds, we can see there's loan club data, we have power plant, okay, weather observations again, and more advanced SQL. So let's talk about the more advanced SQL. There's the loan club data, right? So in the loan club data, we can do some interesting things like we can say, now, since it's a Hive table, and the Hive table is just basically a wrapper or a metadata upon the file, I can say, guess what? I want to know the count of loans and amount by state and bad loans. And we can look at the data and we can see that these are all the loans. This is by Connecticut, Massachusetts, Maine, New Hampshire, Rhode Island, Vermont. So this is New England in the USA. Okay. We can also say, I noticed that there was a problem with the date. So if, okay, it's less than 50 because it's only 2 digits, then I'm going to add 2000 to it because I figure if it's 01, it's probably not a loan from 1901. Computers weren't there back then. However, if it's not that condition, say it's like 86, it might be 1986. We have a loan that's 30 years old. That's typical for paying for a house, maybe. And last but not least, we can do this by adding that CTE, okay, which is right here, and then join it back and do some petitioning. So I want to actually go ahead and do a running total, okay, of the loans. Okay, so now if we go ahead, we can actually take a look and we can see that this is Connecticut, 2011. We started with 40,000. We added a new loan. It's 56,000. So we got 4056. We add 10,000. So we got a running total. So this is quite complex, right? And it's all in SQL. And we could make this a spark.sql dot create a data frame and then write it back out when we have our data engineering. Okay. So what I hope I stressed today, and again, I'm going to wrap up. I'm 1 minute over, and I apologize, Tayob, for going late. Two things. One is that if you learn this right, you're going to be very popular. Okay. A data lake basically is a spoken hub design. Okay. So producers write to the data lake. You can push things into it or pull things into it. Okay. Second thing is that once it's there, you can have many different people using it, like data science models. You can do final curated for reports. Okay. What I found after doing this for 2 years, okay, is there's some important things. Make sure that when deploying objects, creating data lake entries, coding, data factory, sometimes used a lot, use naming standards, okay, conventions, okay, document, okay. In the long run, it'll save you maintenance problems, okay. It'll be good. Both Azure Databricks and Synapse support Apache Spark, and the skills you learned today are transferable between the products. And the future is very bright for those who can adapt, okay. And I'm going to close with that. There's a bunch of references here, and I already gave you the links. So going to stop this, and I will show my face. And thank you again, Ashan, for having me. I really appreciate it.
Thank you very much, John, giving your time and effort to the towards the professional network. We are very much happy to have you with us. Thank you very much. Thank you everyone for attending the session. And I think it's very much interesting for you and it will be very much helpful for your career in future.
And
Hopefully,
you did put me under pressure though. You gave me less than 10 minutes. So if you want to talk 10 minutes next time, we have to start earlier.
actually the things has happened. Sometimes we have to do something that is not predefined scheduled.
I
Actually,
had to shrink
this
my
is
presentation down a little. Hey, Tayob, I'm gonna drop off, but Thomas McShane said hi, by the way.
Okay, thank
oh,
you.
thank you
You
very
know
much.
Thomas, right? Used to work
Yes,
with him.
yes. Yeah, I worked with him for 4+ years. Yes.
Yeah, exactly. I'm working with him at Jim. So have a great talk and a great morning, Tayob, and thank you again, Ashan. I really appreciate it.
Thank you very much. Thank you again.
Bye.
Bye.